Now if you refer the book, no, you get plenty of problems on this one, no, what I'm solving. So rather than solving many problems, better what will happen? Learn the methodology. This what is monoatomic gas? 1 mole, I'll take it. 1 mole of monoatomic gas undergo a cyclic process. 1, 2, 3, 4. Or if you write A, B, C, D, it's left to you. Then, what is the efficiency of gas in one full cycle? So what we have to calculate? Find the if the monoatomic gas undergo a cyclic process 1, 2, 3, 4, 1 in PV diagram. I should. Okay, let's get into the thing. Now, what is the this? I think the first problem. The method is same. I think you open book, you have almost 60% of thermodynamics. All questions are related to this particular method. What I'm going to show. Different shaped. Here I took rectangle, circle will get, rhombus shape will get, but the method will be same for everything. Okay, this is the volume. The first thing. Let me write all things in detail. What is the path 1, 2 first? We have to plot equivalent graphs. So many other things are also. Yeah, we will keep it here. No, now let's come for this one. What is the path 1, 2? Volume constant and pressure increase. So isochoric heating, it should be. So and as isochoric heating, heat will be absorbed. What about 2, 3? Pressure constant. I'm saying this one. You see that volume constant and pressure increase. So isochoric heating. What about 2, 3? Pressure constant, volume increases. So isobaric heating. Isobaric heating, it will be absorbed. Okay, now come for this 3, 4. Volume constant, pressure decrease. So isobaric, so like a isochoric cooling it is. So it will be rejected. What about
Sir,
4, 1?
so 1, 2 should be isobaric cooling, no, sir. Because pressure increases, so volume decreases.
Which one? This one, ma?
Yes, sir.
Volume constant? No, are you not seeing?
Sorry, sir, sorry.
Huh? Okay, this one. Okay, now 4, 1. 4, 1 pressure constant, volume decreases. Volume decreases, temperature decreases. So isobaric heating it is. So it will be rejected. Some basic idea like this. So what are the things? So first we'll go for net work done. So net work done is what, like area under PV graph, because the PV graph, no, this will be much easier. Net work done equal to area in PV diagram. What is area? This will be 3P naught minus P naught. Area of rectangle 2V naught minus V naught. So 2P naught V naught. Okay, this is a net work done by the gas in one full cycle. Okay, where all heat is absorbed in the path 1, 2 and 2, 3. This will be much easier approach. Which one, so like which formula I should prefer? Q positive minus Q negative by Q positive. Which one is very easy to calculate? Go for that. Area under PV graph is work done. So one part is over. Now what is Q1 2? Delta U1 and this should be NCP delta T. So what is a change in intensity of the gas in that particular process? So we don't know temperature, no? Okay, what to do now? So let's, as it is ideal gas equation, So what do we expect temperature here? Let's say T naught, 3 T naught, 6 T naught, 2 T naught. Will I agree? How do I can write? At one, what is the pressure? At one, what is the pressure? P naught, V naught, R T1. So T1 is equal to how much? P naught V naught by R, which is equal to T naught. Next, at 2, 3 P naught V naught R T2. Shall we go for the symbols like this? Huh? This will be much easier. 3 P naught, 2 V naught R T3. And finally, okay, this what I'm just giving symbols. Huh? Like this, you can go for symbols here. Okay, let's go for delta U. What is delta U? N CV T2 minus T1. NCP T3 minus T2. Number of moles 1. Monoatomic gas 3R by 2. T2 is 3T naught minus T naught. 5R by 2. Number of moles is 1. T3 minus T2. 6T naught minus 3T naught. Okay, 2T naught. So 3R T naught. 3, 3, 3, 15, 15, 7.5R T naught. So this will be 10.5 R T naught. It will come. Okay, but R T naught, what you can write? R T naught as P naught V naught. So this is 10.5 P naught V naught. Okay, able to understand now? So this is a thing. So what is the efficiency? How we define efficiency? Network done by Q positive. Network done to P naught V naught. I think, okay, this will do one thing. Let me keep in this way only. 15 by 2,
21 by 2, sir.
21 by 2. This will be better, no? Is it a very good design? Very poor efficiency, no?
Yes, sir.
If you please don't repeat again started. Gunetra, what is the problem, pa? Huh? Please
Sorry, sir.
control. Please, stay away from your mobile, no? See, everyone is paying amount. It's not your own personal. I'm not your personal tutor. Learn. There are so many things to learn. No, why you are adding chorus to teachers? Huh? What is use of that? Okay, efficiency 4 by 21. Huh? So this will be, it's a very poor efficiency, no? So this engine, it's having a very poor efficiency. So if you have designed the engine, definitely what happen? You have to spend more amount to travel from one point to another point. So like that, the engineers, what happen? They will keep on search the new cycles where efficiency can improve and the manufacturing cost should come down. It should be very cheap. This is what the mechanical engineer will be constantly doing it. Okay, this is about the PV graphs. Can we calculate all? Can we plot PT graph, VT graph? Already we did. Once again, different. So already we have temperature, pressure, volume. So first we'll go for PT graphs. I'll take the same graph, so that will be help us to plot the equivalent graphs here. Let's go for no. What is path 1, 2? Path 1, 2 is isobaric. So what you are plotting? Pressure versus temperature. Let's say that there's a pressure. Please do notice very important. This what we have temperature. Temperature will start with T naught, 2 T naught, 3 T naught. No, first I identify points. So like that, sir, like there's a curve. Okay, fine. You can't draw whatever curve you want. What is the method? Identify first point. Don't bother, sir. How the shape of curve? Don't bother. Identify the points. So what is the path 1? Isochoric process. So first what happened? At 1 P naught, T naught. Okay, identify the point. P naught and T naught. There's a point 1. Later on, we'll adjust the shape of the graph. First, we'll identify. Next, again, point 2. Point 2 is 3P naught and 3T naught. 3P naught and 3T naught. Okay, you may forget them, write numbers also. Next again, 3P naught and 6T naught. Fourth one, P naught and 2T naught. What we have to do? Okay, join them. Okay, now, so like a curve like this. Okay, that's all. When you are again joining the points, you should look at the process, then you have to go for it. Is it okay? Just common sense. You have to ask yourself, okay, what shall I do? What is the method? These are the questions what we have to ask ourselves here. So now, next, what I do is like from 1 to 2. Okay, what is 1 to 2? Is isochoric process. In PT graph, isochoric process, straight line passing through origin. 2, 3, isobaric eating, horizontal line in PT graph. 3, 4, isochoric cooling, straight line passing through origin. Strictly straight line passing through origin. The basic condition. Okay, got this? This is what the PT graph. In books, what happens if you go for books, no? One question will be there for you that find the efficiency. One question will be there, this one. The same numerical you are doing twice or thrice, that one. So I suggest you like plot equivalent graphs. You come to know that what you are discussing for this is same thing for you. Of course, the writing formulas will be different. Okay, this is about the PT graph. Okay, let's go for VT graph. Volume versus temperature graph. Please do make observation. Some very important things will be there. What is volume V naught to V naught? So volume of the gas will be as usual, temperature T naught, 2T naught, 3T naught, 4T naught, 5T naught, 6T naught. Okay, now identify the points. V naught T naught, 0.1. Okay, V naught T naught, 0.1. Then again, V naught and 3T naught. 2V naught, 6T naught. Fourth one, 2T naught, 2V naught, 2T naught, 2V naught. Okay, we have to join the curve. 1, 2, isochoric heating. 2, 3, 3, 4. But again, we have to take care what like VT graph should be straight line passing through origin. Roughly may not be. Okay, I think this curve little bit. Let me plot this one because it will give wrong idea for students, everyone. Yeah. Okay, this will be 4, 3, 2. Okay, there's a method. See, like again. Okay, look at this PV graph, clockwise cyclic process. You have to see what is it? It's a clockwise. Huh? I think I'll write instruction clockwise. It is. What about this? This is also a clockwise. What about this? This is a counterclockwise, anti-clockwise. I write it. I think very important. In VT graph, anti-clockwise cyclic process, what will happen? Efficiency will be positive. PT graph, clockwise cyclic process. Are you able to notice? PV graph, clockwise cyclic process, work done positive. Please notice in PV graph, clockwise cyclic process, work done positive. PT graph, clockwise cyclic process, work done positive. In VT graph, volume versus temperature, counterclockwise cyclic process. Then what we get? Work done will be negative. Able to notice this difference? Very important. It's going to help us a lot. Okay, this is about the pressure, PT graph, PV graph, VT graph. Let's go for one more graph is there, intensity versus density. I think let me introduce that here, that also now here only. I think I'll pull it these things here. Let me go for intensity versus density graph. Able to see things clearly? Okay, the last one, intensity versus density graph. Now, what is intensity? So let me plot or density versus intensity. Euro. But we don't know anything about the intensity, no? So whose help we have to take it here? We don't know anything about intensity. Intensity directly proportional to temperature. So therefore I'll go for like this. U naught. Let's go for this one. So U naught, 2U naught, 3U naught, 4U naught, 5U naught, 6U naught. What about the densities? Rho naught by 2 and rho naught. Why rho naught by 2? Because what about the volumes? Volumes will take V naught and 2V naught, no? When volume of gas is V naught, density will be rho naught. When volume of gas is 2V naught, density will be rho naught by 2 because overall mass should remain same. Will you agree this? Density mass is equal to density into volume. So rho naught by 2 should be equal to 2V naught. So when volume of gas is 2V naught, density should be rho naught. When volume of gas is V naught, it should be rho naught. So there is some overall mass should remain same. Okay, let's identify the points here now. So what is the method here now? I think let me take this graph only. Why to go for other one? Let me take this graph only. Okay, now when temperature is T naught, intensity will be U naught. What is the density of gas will be rho naught. So shall we go for the first point? Identifying the first point. This is a point one. Then when volume of gas is V naught, the temperature is 3T naught. So volume of gas is V naught means density should be rho naught only. And what should be the this particular thing? 3T naught it should be. 3T naught, so 3U naught. Okay, therefore the point will be 3U naught. Okay, what about point 3? 2V naught. 2V naught means V naught by 2. V naught by 2 and 6T naught. Okay, there's a point. 3. So what about the point 4? 2U naught and rho naught by 2. Okay, what about the graph? So the graph will be 1, 2. Okay, what to do? 1, 2 isochoric process, no? Volume constant, density also constant. So therefore, this is the one thing. Next, 2, 3. 2, 3 is what? Oh, I didn't plot here. Solid curve. What about 2, 3? Isobaric process. No. In intensity versus density graph, what should be the curve? Isobaric process. Rectangular, hyperbola. 3, 4, isochoric cooling. Again, rectangular, hyperbola. Once a student learn this, he can manage any problem. He should learn the methodology here. That's all. Like this, you can keep on plot the different graphs. Pressure versus volume, we have no. Density versus pressure also you can plot it. Like that, a student has to take help of the basic geometry. There's no concept here. Your high school geometry should be very good. Okay, not only just efficiency, a student should also learn how to plot the equivalent graphs. Okay, shall I go for next one? Next, again, next shape of graph. So there's a, okay, I'll bring the PT graph. Okay, let me take the next one.